Let's take a look at this next question. We want to form a polynomial whose zeros are -2, 4, and 3. And we want it to have a degree of 3. That means our highest exponent for this polynomial should be 3. So for part A, we want to go ahead and write this in factored form. And keep in mind your factored form means you're going to have sets of parentheses. And we're going to use the information that this polynomial is going to have a degree of 3. So that implies we should have a total of 3 sets of parentheses. Now, the stuff inside those sets of parentheses might be the same. That depends on the other information that's given to you in the problem. And as we build these sets of parentheses, remember that it's going to be in the form x minus our 0 or our x-intercept. So let's go ahead and take a look at this first one. We have a 0 of -2, so we've got x minus a -2. And we can go ahead and rewrite this. We can clean up our signs. X plus 2. For our second set of parentheses, we're going to have x minus, our next 0 is a 4. So we've got x minus 4. And for our third set of parentheses, we're going to have x minus our 0 of 3. So x minus 3 will be our last one. And so here's our polynomial in factored form. Let's take a look at part B. We want to know what's going to happen to our graph if we have an a value of -1. So let's go ahead and write this out with our polynomial. Alright, this time we're going to put a -1 in front of those sets of parentheses. And if we took a look at our graph, remember what happens when you have a negative out in front. This is going to cause a reflection over your x-axis. So it's going to turn your graph upside down. Your x-intercepts or your zeros are not changing at all, but your graph would be upside down. And you can go ahead and type that in to Desmos, and you can go ahead and try it on your own so that you can see what it looks like. For part C, we want to know what happens if our a value is 2. Right, so this time that a value out in front is going to be a +2. So here's our function. And remember that when you have a number out in front that's bigger than 1, this is going to cause a vertical stretch to your graph. By 2. Right, so you would be multiplying your y values by 2. Those x-intercepts are going to stay the same. And for part D, we want to go ahead and write our function in expanded form. So let's go ahead and jot down what we had for our factored form. Remember, this was x plus 2 times x minus 4 times x minus 3. This was our factored form. Expanded form means you want to multiply it out. And so if we're going to multiply this out, we're going to have to use distributive property. It doesn't matter what 2 sets of parentheses you use first, but you're going to have to go ahead and distribute the 2 sets of parentheses first, or FOIL it out, and then we can go ahead and multiply it by our third set of parentheses. Now, most of you are going to know what I'm talking about when I say this. A lot of you have probably multiplied polynomials using what I refer to as arches and rainbows when you're foiling. You're more than welcome to do that. However, I'm going to go ahead and multiply using the box method, which is the same exact process, but it's a little bit cleaner so that you can make sure that you don't miss any terms. It's easier to find your errors if you happen to make them. So let's go ahead and multiply this out. I'm going to go ahead and multiply the x plus 2 by the x minus 4 first. And it doesn't matter which set of parentheses you put on top and which one you put down the side. Just make sure that you get your signs correct. So I'm going to put x plus 2 across the top, and I'll go ahead and put my x minus 4 down the side. And you're going to multiply to fill in the boxes. So just like you would if you were foiling, right? X times x is going to give me x squared. X times a positive 2 is going to give me a positive 2x. And then for my second row here, I'm going to take the negative 4 and multiply it by each thing that I had up on top. So negative 4 times x will give me a negative 4x. And negative 4 times a positive 2 will give me a negative 8. Right, and now I can go ahead and combine my like terms. You'll notice here that on this diagonal, both of these are x terms. So it's going to be a little bit easier here to combine those. So this is going to give us x squared minus 2x minus 8. So after we multiplied that first set together, we got this x squared minus 2x minus 8. And we still need to take this trinomial and multiply it by the x minus 3. Alright, so I'm going to go ahead and set up my box method one more time. I'll put my trinomial across the top. So I've got x squared minus 2x minus 8. And I'm going to go ahead and put my x minus 3 down the side. So I should have 6 terms total when I multiply these together. This is why I say I kind of like the box method so you don't miss any terms. Alright, so let's go ahead and fill in the top row. We're going to take this trinomial and multiply each term by x. Be careful with your exponents here. X times x squared is going to give me x cubed. X times a negative 2x will give us a negative 2x squared. And x times negative 8 is a negative 8x. Let's go ahead and do the same thing for our bottom row. This time we're multiplying by that negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times a negative 2x. So positive 6x. And negative 3 times negative 8 will give us a positive 24. Alright, so we've got all 6 terms. You'll notice that your like terms are here on your diagonal. So we can go ahead and combine those. So we've got x cubed minus 5x squared. For our x terms, we're going to get a negative 2x. And then we have our positive 24. So this would be the expanded form of our polynomial. Okay, and you can double check that it matches the information that you started with. You were given information up here that says it should have a degree of 3, and it does because your highest exponent, right, for this expanded form of the polynomial is a 3.